Hello. Today we will discuss about solution of first order differential equation. So in this course we are going to use the numerical methods for solving differential equations. So at the first we will discuss about what is the meaning of differential equation, first order differential equation, and then we will try to discuss about the numerical methods. So in this numerical methods we are going to use Runge-Kutta method, mainly Euler's or Runge-Kutta methods, and we'll try to get how to increase the accuracy of the solution. So let me just start this thing. So Euler method or Runge-Kutta method. So at first, a simple differential equation will be expressed as this particular equation. So what we are, if you have a function, say function is represented at y is f of x, a function is there. So this particular function can be plotted over this particular curve. So along this axis you are plotting function and here the value. So for the different value of x you have a different value of this y or the function. So the blue curve is representing the nature of the function, an arbitrary function we have taken. Now the differential equation is basically the slope over this. So the meaning of the slope is that, so if you have a curvature, you can see along this particular direction, let me take a different color, so green color I am taking. So if you are considering this particular side, so you can consider the nature of the curve is something like this. Whereas in the other side you have a curvature something like this, which is a different one. So what is the change in the slope will be given by this differential equation when you are differentiating over this particular. Now what is the meaning of this thing? You are considering the different values of x, say a uniform difference between the x values I have considered, and for the each and every values of x, what are the values of y? So say for x0 you have a corresponding function value of y0, and x1 you have a function value of y1. Now we can see the differences between this y1 and y0 and x1 and x0. So this will give some idea about this particular variation. Same way one can consider this point and another point somewhere here. So this point I am considering as x1 dash. So we will get a corresponding function y1 dash. So same way you can find a slope for this particular side. So obviously this side slope and this side slope will be different. So this is the idea about the first order differential equation. So here now we will consider the numerical method by which one can find the solutions. So the first and the simplest way to find this differential equation is by considering the next value, say x1. So the initial value is x0 and the next value is x1, and the difference between this x0 and x1 is h. So this is simply written as x1 is equal to x0 plus h. So the coordinate, by using the simple coordinate geometry, so one can write the y1 function value. So y1 function value as y1 is equal to y0 plus h, this function of this. So from where this comes? Say if you have a function, if you are talking about this particular value is the slope at the point x0, y1. So you are representing this thing. So what is the meaning of x0, y0 point slope? Simply given as y1 minus y0 divided by x1 minus x0. Now we know the difference between x0 and x1 is h. So we can simply replace it by h. So rewriting this one, so one can get y1 is equal to y0 plus h into that function value f of this function. So this expression is given. So if you have a very small value of h, so one can get x0 corresponding y0 here, then you can get x1, a very small distance, say h you are considering somewhere here, so you will get a corresponding value of y1 here. Same way you can get x2 just nearby to this, so you will get a y2 value somewhere here. So if you have a very close value, so you will get a very accurate values of this particular solution. Now how to solve this problem? Say if you have a y1, then you can get y2. Obviously the same way we can get a y2 from this thing. So a general formula one can write yi plus 1. So actually this is the initial value and this is the final function value. This is y and the corresponding slope value of the system. So now we can consider a particular numerical problem and I will see how to solve this particular problem. So we have taken a function, a differential equation y dash. This is equal to minus of 2x. Now what is the meaning of y dash? Y dash can be written as dy dx, or this can be written as a function. That means the slope function at x0, comma y0. So what you have to find? You have to find the function y at point 0.5. So here x value is 0.5. And the value started from x0. So where x0 is 0, so first value is x0 is 0 and y0 is minus 1. So we can just refer this particular problem, particular curve. So x0 value is given, y0 value is given. So you need to find its next value. Means you need to find what is the y1 value of this one. So you have the initial value. So y of 0, that means x0. This is minus 1. And the step size, that means the gap between the x0 and x1, this is given as 0.1. So one can simply use the formula to calculate the thing. So y1 is equal to y0 plus h into x, the slope at x0, y0. Okay, so we can put this value. So what is the value of y0? So y0 value is minus of 1. So this is given. What is the value of h? H is given as 0.1. So you can put this value. Now we need to find the function at x0, comma minus 1. So what is this? Is x0 and y0. Now what is this value? So you know y is given as f of x0, y0. Okay, so now put these values. So you have minus 2 x minus y. Put these values and you can calculate this thing. So what you have here? Okay, so put these values. X0, here x0, the first value here, this is x0 and this is y0. Obviously we are taking the first one. So x0 is 0. So if we put this one, so this factor will be 0. And y is minus 1. So minus 1 and minus 1, this will give you 1 in the system. So we can put it back in this equation. So we'll get the y1 value. What is your solution for the first? Okay. Now we can go for y2. Actually, we need to calculate it for y5. So you need to go for some other steps to get that one. So again, you can get y2. So what is y2? y2 is y1 into h x1 y1. Now, what is y1? We have already calculated y1 from that earlier equation. So put that back in this equation. So y1 value comes minus 0.9. So put it here. What is the value of h? This is constant. This is given as 0.1. So this value is now we need to find the function at x1, y1. What is x1? x0 is 1 and h value is 0.1. So x1 is simply given as x0 plus h. Now x0 value starts from 0 and h is 0.1. So obviously x1 value is 0.1. So that's why the function is written as x1 is 0.1. Now what is the value of y1? y1 value we have already calculated it. Now we have to put this thing in the function. What is that function? Function is this one. Minus 2x minus y. Now here x will be x1 and y will be y1. Put it back and you will get that. Now this is y1. That means this is the value at x.1. This is the value at x.2. Now you need to calculate y3. Sorry. You need to calculate y3. So what is y3? y3 means x is equal to at 0.3 because each and every step increment this is by 0.1. So we need to calculate y4 and y5. So y5 will be x equal to 0.5. You are asked to calculate what is the value of y5 at x equal to 0.55. Okay, so this is a simple way one can calculate this. So now in this method you can easily calculate this problem, you can easily solve this problem, but the accuracy of the method is not that high. So you need to modify this one. So the modified one is given by the modified method or the midpoint method. Now what is the meaning of midpoint? Now here we are going to consider the midpoint as, in earlier case we have considered x0 and x1, and the gap between x0 and x1 is h. Now here we are going to consider some other point in between these two, at the center point of this one. So although this information is not given to this problem, but as we are considering this particular points, you will get some idea about this point. So if you have a information, so if this is very close to each other, now the midpoint of this one will be much closer. This will give you some higher accuracy. So the midpoint method give a higher accuracy. So how to solve this problem and what is the formula we need to use? Now here the formula is y m plus 1 ym. That means you are considering the iterations. Now see the problem. So here the function is given as, so the solution is almost similar. y1 is equal to y0 or yi plus 1 or m plus 1, so y plus h into the function x and y. Now the question is which x value will be considered, which y value will be considered. For earlier problem we have considered the initial value of x and initial value of y. But here as is midpoint problem we are not going to consider this thing. Rather this particular x will be modified, this particular x and y will be modified. And what is this modification? Now see, x is given as that initial value plus h by 2. Not the whole h, this is h by 2. So this particular part. So x is modified one. And what is y? Now see, y is also modified. So what y was taken? Y was taken at the initial point plus half of h into that function. So by using this method you are trying to get more information in between the x0 and x1 or xn and xn plus 1. As you are getting more information, your solution having higher information, or you can get lesser approximation. Now check how to solve this problem. Again we have taken the same problem, minus 2x minus y. So initial value is given and the initial function value is given. Again step size also consider as 0.1. So these values are written over there. Now we need to use this particular formula to calculate y 0.5. So what is this? Just look at here. So here function x0 y0, first you need to get what is x0 y0. You can get one, you can get this thing. So you will get information about this particular function. Okay, now this will be multiplied by h by 2. You know what is h and what is h by 2. What is ym? So now in the initial case ym is equal to 0. Now what is y0? Y0 is minus 1. Now if you put those values, so you will get minus 1 plus h by 2, that means h by 2, 0.1 by 2, and function is minus, this is 1. Okay, so you will have this particular part. And what is xm plus h by 2? What is xm? The initial case, this is x0 plus h by 2. Now you know what is x0? x0 is 0 and h is 0.1 by 2. Okay, so put the values in the function, put the values of x. So this will be considered as x value, the whole will be considered as x value, this whole will be considered as y value. So put this value and you will get that one. So now here x value is 0.05 and minus 0.95. Now what are those values here? This is not x0, rather this is x0 plus h by 2 somewhere here, and its corresponding y0, midpoint value is also here. So you can just consider this is y x half, that the midpoint what you are considering, and this is y half. Although we don't have this information, but we are trying to calculate this thing to get a higher accuracy. Get that one? Okay, when you have this thing, put it back in this equation. So now this gives you the information about y1. So what is the y1? Y1 is at x equal to 0.1. It starts from x starts from 0. The first value of x is 0. Okay, and x, this particular gap is h, and this is x1. X1 is 0.1. Okay, so you have this one. Now again, when you have a y1, you can calculate what is y2. Now remember, when you have y1, so you are having that initial values x0 and x0 and y0. Now when you are calculating y2, now you need to calculate it for x1 and y1 in place of x0 and y0. Put these values again. So first you get the slope, first you get the function, okay, then the value of x, then the value of y. Put it back in this equation, you will get the function value. And then put this back in that particular formula. When you have, you will have y2. Now this is y2, y at 0.2 when x value is 0.2. Get that one. Go for your third accuracy, 0.3, 0.4, 0.5. You will have the value for this particular function. Next comes some other accuracy. Okay, so now this method is known as the second order method, Runge-Kutta second order method. The first one is known as the Runge-Kutta method. It's a zeroth order method or the first order method. Okay, so now this method will be modified in this case. So there are two formulas. This thing. So here y1 is given as y0 plus k1 by k2. Just remember the earlier one, the first order method. This is given as y1 is equal to y0 plus h into the function value f. x0 and y0. Okay, but here we are considering some other accuracies. Just look at this. What is k1? K1 is h f x0 y0 has been this particular thing. But there is plus k2, some other accuracy. What is that k2? K2 is f of x0 plus h. So we are considering x0 and this is x1. So this distance is h. Okay, and the y value was considered as y0, that initial value of y, this will be somewhere here, plus k1. Plus k1. What is k1? K1 is this. Okay, so you can get k1 and k2 divided by 2. Addition with that initial value of y, you will get the final value of y for this thing. The solution for this particular. Or you will have another method. The same way you can get k1 and k2. So there are two methods, two different techniques by which one can get almost a accurate type of calculations. Now what is this particular case? So this particular case is h f0, h f x0 plus h was the earlier one. This is h by 2. So obviously this will give you some higher accuracy, h by 2. So what is h by 2? So initially this is x0. Here you have x1, this is h. So now we are considering half of this one. Okay, half of this one. And also this is k1 by 2. So could go for this one. h1 is equal to h0. So initial value of y and the final value of y is this thing, you can calculate this one. Go for the formula and calculate this thing. So again we have taken the same function. Minus of 2x minus of y, initial value is 0 and the y value is minus 1, step size is 0.1. Put these values in this formula. Calculate what is k1. Okay, k is h, f x0 y0. Put those values, calculate this one. What is k2? k2 is h f function at x0 plus h, y0 plus k1. Put the value of k1 over there. So this becomes a function. This becomes a function. And now what is that function? Function is given here as minus 2x minus y. So put these values. Put these values in this equation, you will get k2. So you got a k1 and k2. Put this thing in this equation, you will get y1. Again, y1 it for at x equal to 0.1. So now we need to calculate y2, y3, y4 and y5. So y5 means this is a value at x is equal to 0.5. Get that one. Repeat the steps, you can get this. This is by using the method 1. So same way you can use the method 2. Same type of problem we can proceed for this thing. So get k1. You know how to get the k1, and this becomes the k2. Okay, sorry. This becomes the k2. So get that one. K1 plus k2 divided by 2. You can get that form. Now come with that third order Runge-Kutta method. Now see, third order Runge-Kutta method will also have some corrections. This is k1, k2 and k3. So K1, you know how to get K1. You know K2, that in earlier problem we have already discussed about what is K2. H f of x0 plus h by 2, y0 plus half of K1. So get that thing and put it back in this formula. And what is K3? Now see, K3 is h into f of x0 plus h, and the y value is given as y0 plus K1 minus 2K2. So you know K1 and K2, put this back in this formula. Now in the same way you can calculate what is the value of y in this case. Consider the same problem. Minus 2x minus y, x is 0 initially and y is minus 1, and this is 0.1. Put these values, calculate. What you have to calculate? K1, you have to calculate K2, you have to calculate what is K3. Now put this thing in this formula. Put this thing in this formula. Which formula? y1, y0, 1 by 6 K1 plus 4 K2 plus K3. Put the value of K1, K2 and K3 and you can get y1. Then again you need to calculate y2, y3, y4 and y5. Now in this case 5 value is 0.1. Get that one. And that is the last one, last method, which is known as the Runge-Kutta fourth order. Now see, in this case we have K1, K2, K3 and K4. There are 4 Ks are there. K1, simple, taken that earlier one. K2, we have that earlier one. K3, yeah. Now K3 we have to consider h f of x0 plus h by 2, again the midpoint, and this is y0 plus K2 by 2, so half of this one. And what is K4? K4 is given as x0 plus h and y0 plus K3. Now we have the values of K1, K2, K3 and K4. You need to calculate the function here. Function n comma yn. Now in this case, in our next problem, or what problem we are considering, the problem was considered as, the function was taken as minus of 2xn minus yn. So get the values of x and y, get the values of x and y, get the values of x and y, get the values of x and y for K1, K2, K3 and K4. Put this thing in this formula. Now when you have, now we can put it back in this, multiplied with 1 by 6 and add it with the initial value of y, that you will get the final value of y1 from this. Final value of y1 from this. So these are the methods by which one can calculate, one can solve simple one-dimensional differential equation. The advantage of this particular method, the Runge-Kutta method, is this method is very accurate. Obviously this is very accurate. Versatility is also very high, so you can use it for higher order also, and you can write a simple program for this particular methods. Adaptability is also very high, but there are some disadvantages. Disadvantages is that as we have number of K1, K2, K3, K4 values, when you have to get a higher value of accuracy, you need to give a higher cost. A computational cost should be very high. Okay, as we have high cost of this one, obviously the memory space, you have to take different values of K1, K2, K3. For each and every cases you need to calculate the function values. So obviously the memory space required is very, very high. So here, if your function is simple, then the problem is very simpler. So you can write a program and you can solve this problem. But if the the differential equation is very complicated, so the problem will arise over there. So you really cannot use this thing. At some time you need to think about the stability of this particular problem. So now you can I get some idea about the stability of the problem is that you try to find the solution of the slope of this particular system, the first order derivative. So you need to converge this problem so that you will get a very, very higher accuracy. But if you are trying to find your solution somewhere here, but if anyhow if you miss this thing, so you are shifting from this particular point to this particular point, you will be slipping down from this point to this point or this point, this particular point. So this will give you high chances of error in the system. Okay, so this is one of the disadvantage of this Runge-Kutta method. Otherwise this problem is very, very simple. Thank you all.